Imagine, right at this very moment, while you're watching this video, it feels like you're sitting comfortably in your chair. Your home is quiet. Your city is exactly where it should be. Even Earth appears to be standing still. But the truth is something else entirely. At this very moment, Earth is racing around the sun at nearly 100,000 kilometers per hour. The sun itself is orbiting the center of the Milky Way galaxy at nearly 800,000 kilometers per hour. And even more astonishing than that, the entire Milky Way galaxy, containing more than 100 billion stars, is also moving through space toward a mysterious direction, at nearly 2.2 million kilometers per hour. But the question is, where are we going? What is pulling us? Is there a gigantic black hole out there? Is there an ocean of dark matter? Or is there something in the universe that we still haven't been able to see? Scientists gave this mystery a name, the Great Attractor, a cosmic puzzle that has troubled astronomers for decades. And today, we are going to descend into the deepest part of this mystery. But before we can understand this mystery, we need to understand where we actually live in the universe. Our story begins with Earth, this small blue planet, the only known world where life exists. Then comes our solar system, the sun and the planets that orbit around it. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. But even the solar system is incredibly small. Now let's move farther back, much farther, and farther still. Now the Milky Way galaxy comes into view, a gigantic spiral galaxy containing somewhere between 100 and 400 billion stars. Our sun is just one ordinary star among them. If the Milky Way were the size of Earth, our solar system would be smaller than a grain of sand. But the story does not end there. The Milky Way is not alone. Around it exists more than 80 small and large galaxies. Together, they form a collection known as the Local Group. The largest member of this local group is the Andromeda Galaxy, a galaxy that will one day collide with the Milky Way. But that is a story for another time. Now let's move even farther back, and suddenly, thousands of galaxies begin to appear. Galaxy clusters, then superclusters, and then an enormous structure. So enormous that it stretches across nearly 500 million light-years. Its name is Laniakea. In the Hawaiian language, it means immense heaven, a vast cosmic paradise. This is our cosmic address. Our Milky Way is part of the Laniakea Supercluster, but now a question emerges. If the universe is expanding in every direction, why are we moving in one particular direction? This is where the real mystery begins. In 1929, a great astronomer changed the world forever. His name was Edwin Hubble. He discovered that the universe is not static. It is constantly expanding. Every galaxy is moving away from every other galaxy. Just like dots drawn on a balloon move farther apart as the balloon inflates. This became known as Hubble expansion. Scientists believed they finally understood the motion of the universe. But then, a strange problem appeared. Some galaxies were moving faster than expected. Some were slower. Some were moving in entirely different directions. Why? Imagine a river flowing downstream. You are sitting in a boat. The river is carrying you at 10 kilometers per hour. But then you start the boat's engine. Now your total speed becomes 15 kilometers per hour. 10 because of the river, 5 because of the engine. Scientists call this extra motion peculiar velocity. And when they measured the peculiar velocity of galaxies, they found something very strange. It appeared as though thousands of galaxies were being pulled toward an invisible gravitational source. That was the moment when the story of the Great Attractor began. During the 1980s, a team of scientists began investigating this mystery seriously. The team was led by Donald Lynden Bell. The group was given a nickname, the Seven Samurai, because there were 7 principal scientists involved. They studied hundreds of elliptical galaxies. They measured their distances. They measured their velocities. And then they created a map. When the results came in, the scientists were stunned. Nearly all the galaxies appeared to be flowing in the same direction, as if a gigantic, invisible waterfall existed in space. That direction pointed toward the Centaurus and Norma regions. But what was there? A supermassive black hole? A massive galaxy cluster? Or something else entirely? No one had an answer. But one thing was clear. Something enormous existed there. Something so massive that it was changing the motion of galaxies located millions of light years away. And this mysterious region became known as the Great Attractor. But there was a problem. When scientists pointed their telescopes toward that direction, they could barely see anything at all. Why? Because standing directly in their way was our own galaxy. And that is where the most mysterious chapter of our story begins, the zone of avoidance, a region where the universe has hidden its secrets. And for decades, those secrets remained hidden. Every time astronomers tried to look toward the Great Attractor, they ran into the same obstacle, a gigantic cosmic curtain. Not a distant galaxy, not a black hole, not dark matter, but our own Milky Way galaxy. Our galaxy looks beautiful from the outside, a magnificent spiral of stars stretching across space. But for astronomers, it can become a wall made of billions of stars, massive clouds of gas, and vast rivers of cosmic dust. Dust so thick that it blocks the light coming from galaxies far beyond it. Imagine standing in a dense forest. Somewhere beyond the trees, a giant mountain exists, but the trees are so dense that you cannot see it. That does not mean the mountain is gone. It simply means something is hiding it. And that was exactly the problem astronomers faced. The Great Attractor was there, but something stood in the way. Astronomers called this hidden region the zone of avoidance, a place where the universe seemed to disappear. For decades, the Great Attractor remained hidden behind this cosmic curtain. But eventually, scientists decided to try something completely different. Instead of looking with ordinary visible light, they began looking with other forms of light, because the universe is much bigger than what human eyes can see. Visible light is only a tiny fraction of the electromagnetic spectrum. Beyond it exist radio waves, infrared radiation, ultraviolet light, X-rays, and gamma rays, each one revealing a different version of reality. And that is when the Great Attractor investigation turned into a cosmic detective story. The first step was infrared astronomy. Infrared light can pass through dust far better than visible light. Suddenly, scientists could see parts of the hidden universe that had remained invisible for decades. Then came powerful radio telescopes. They revealed even more structures hidden behind the Milky Way. But the real breakthrough came from X-ray astronomy. Because galaxy clusters leave a very special signature. A normal galaxy may not shine brightly in X-rays, but giant galaxy clusters do. And the reason is astonishing. Between the galaxies inside a cluster exists an enormous amount of gas. This gas can become heated to tens of millions of degrees, so hot that it begins emitting X-rays, which means if a giant hidden galaxy cluster existed behind the Milky Way, X-ray telescopes could find it. And that is exactly what happened. During the 1990s, a space observatory called ROSAT was scanning the sky. ROSAT was designed to observe the universe in X-rays. It surveyed the entire sky, searching for hidden cosmic structures. And then, behind the zone of avoidance, it detected something extraordinary. A powerful X-ray source, a gigantic concentration of matter. Astronomers immediately became excited. Perhaps they had finally found the Great Attractor. Further observations followed, more data arrived, and slowly a picture began to emerge. Hidden behind the Milky Way was an enormous galaxy cluster. Its name was the Norma cluster. also known as Abell 3627. This was not an ordinary cluster. It contained hundreds of galaxies. Its total mass was equivalent to trillions of suns. It was one of the largest structures in our local universe. For a moment, everything seemed to make sense. Many astronomers believed the mystery had finally been solved. The Norma cluster must be the Great Attractor. Case closed. But science rarely works that way, because when researchers performed detailed calculations, a new problem appeared. Norma was massive, extremely massive, but not massive enough. It could explain part of the motion, but not all of it. It could not fully account for the peculiar velocity of our local group. Something was still missing. It was like finding a suspect at a crime scene, only to discover that the evidence pointed toward an even bigger mystery. Once again, the Great Attractor slipped out of reach. The deeper scientists looked, the more complicated the picture became. And then they noticed something else. The Norma cluster was not alone. Far from it, surrounding it were additional clusters, additional galaxy groups, additional concentrations of matter, hundreds of galaxies, then thousands, all connected together, part of an enormous cosmic network. And suddenly, scientists realized they might have been asking the wrong question all along. What if the Great Attractor was not a single object? What if it was not one galaxy cluster, not one hidden structure? What if it was something much larger, a gigantic interconnected system, a cosmic river network where galaxies flowed like leaves carried by invisible currents? That idea changed everything, because instead of asking, "What is the Great Attractor?" scientists began asking, "How do galaxies move through the universe?" And that question led to one of the most remarkable discoveries of the 21st century, Laniakea. In 2014, researchers analyzed the motions of thousands of galaxies, not just where they were located, but where they were actually going, and the results were astonishing. When the data was mapped, the universe appeared to contain invisible rivers, cosmic currents, gigantic flows of galaxies moving through space. Galaxies behave like leaves floating downstream, each following the pull of gravity, each carried along invisible pathways. And by tracing these cosmic flows, scientists identified an enormous region of space, a region containing nearly 100,000 galaxies, a structure stretching across roughly 500 million light-years, a scale almost impossible to imagine. They called it the Laniakea Supercluster. In the Hawaiian language, Laniakea means immense heaven, a vast cosmic paradise. And the most exciting part of all? Our Milky Way belongs to it, which means we are not only residents of the Milky Way, we are residents of Laniakea. This is our true cosmic address: Earth, the solar system, the Milky Way, the local group, and beyond all of them, Laniakea. But the mystery was still not over, because another question immediately appeared. If Laniakea is so enormous, then is the Great Attractor simply the center of Laniakea? Is that the final answer? Or is something even bigger hiding beyond it? Scientists would soon discover a structure so vast that it threatened to rewrite the entire story. A structure larger than the Great Attractor itself, larger than anything they had expected to find. Its name was the Shapley Supercluster, and what researchers discovered there would force them to completely rethink everything they thought they knew about the Great Attractor. Because the deeper they looked, the stranger the picture became. For years, scientists had believed that the Great Attractor was the ultimate destination, the final answer, the hidden source pulling galaxies across millions of light-years. But as observations improved and telescopes became more powerful, a shocking possibility emerged. What if the Great Attractor was not the end of the story? What if it was only one stop along a much larger journey? When astronomers looked even farther beyond the Great Attractor, they found something extraordinary, something even larger, Even more massive, a structure so immense that it challenged everything they thought they knew. Its name was the Shapley Supercluster, one of the largest known concentrations of matter in the nearby universe, containing thousands of galaxy groups, thousands of galaxy clusters, and an unimaginable amount of mass. To understand its scale, imagine that a single galaxy cluster is a city, then the Shapley Supercluster would be an entire continent. And yet, even from hundreds of millions of light years away, its gravity may still influence us. And that raised an important question. Are we really moving toward the Great Attractor? Or are we actually being pulled toward the Shapley Supercluster? Or perhaps toward both? The answer was not simple, because new cosmic flow maps revealed something remarkable. Galaxies were not moving toward a single destination. Instead, they appeared to be influenced by multiple enormous gravitational regions, like currents in a vast cosmic ocean, some pulling in one direction, others pulling in another, and together they created the complex motion we observe today. Suddenly, the universe no longer looked simple. It looked like an enormous network of gravitational rivers, and we were flowing inside them. But hidden within this mystery was another invisible player, something we cannot see, cannot touch, and yet, without it, the entire story falls apart. Its name is dark matter. Everything we can see in the universe, stars, planets, galaxies, nebulae, even black holes, combined together, account for only about 5% of the universe. Just 5%. The remaining 95% is something else. Roughly 27% appears to be dark matter, and nearly 68% appears to be dark energy. Dark matter does not emit light, which is why we cannot observe it directly, but we can see its gravitational effects. Just as the wind is invisible, yet reveals itself by moving the leaves of a tree, dark matter reveals itself by moving entire galaxies. Many researchers believe that enormous concentrations of dark matter may exist within the Great Attractor region, perhaps helping drive the powerful motions we observe. But the mystery goes even deeper, because astronomers possess another piece of evidence, one that has traveled across the universe for almost its entire history: the cosmic microwave background. In 1965, two scientists, Arno Penzias and Robert Wilson, detected a strange signal coming from space, a faint microwave glow, arriving from every direction. At first, they believed it was interference, perhaps a problem with their equipment, but eventually, they realized they had discovered something extraordinary: the oldest light in the universe, a relic from the Big Bang itself, the cosmic microwave background, or simply the CMB, a snapshot of the universe when it was only about 380,000 years old. When scientists studied this ancient light in detail, they noticed something unusual. One side of the sky appeared slightly warmer. The opposite side appeared slightly cooler. This effect became known as the CMB dipole, and it revealed something remarkable. Our galaxy is moving through space at roughly 600 kilometers per second, which means the evidence for our motion does not come only from galaxy surveys. Even the oldest light in the universe tells the same story. We are moving. The question is, where? And then came perhaps the biggest twist of all. Decades of observations, supercomputer simulations, cosmic flow models, and increasingly precise measurements forced scientists to ask a radical question. What if there is no single great attractor? What if we misunderstood the story from the beginning? Recent analyses suggest something fascinating. No single structure appears capable of explaining all of our motion. Instead, Virgo cluster, Norma cluster, the Shapley supercluster, dark matter filaments, and other enormous structures may all contribute together, creating the motion we observe. In other words, the Great Attractor may not be a single object at all. It may be a collective effect, A cosmic gravity network, a vast interconnected web stretching across hundreds of millions of light years. And that realization changes everything. Because now, when we look at the universe, we no longer see isolated galaxies. We see a gigantic cosmic web, immense filaments of matter stretching through space, galaxy clusters sitting at their intersections, superclusters connected together. And somewhere within this enormous structure, our Milky Way, a tiny island of stars, drifting through an ocean of gravity. Perhaps that is the true secret of the Great Attractor. Not a monster, not a giant black hole, not an alien megastructure hidden in the darkness, but the natural architecture of the universe itself. A cosmic symphony of gravity, where entire galaxies move to a rhythm billions of years in the making. And now, the most important question of all, will the Great Attractor ever consume us? The answer is no. Almost certainly not. The universe continues to expand. Dark energy continues stretching space itself. And over vast stretches of time, the influence of distant structures becomes weaker. We are not racing toward a catastrophic collision, but we are part of something far greater. A cosmic river. A journey already billions of years old. And perhaps that is the most beautiful part of the story. Because the next time you look up at the night sky, remember this. You are not standing still. You are traveling. With Earth, with the Sun, with the Milky Way, with Laniakea, through a universe that still hides some of its greatest secrets. And somewhere out there, among those invisible rivers of gravity, the full story of the Great Attractor may still be waiting to be discovered. And if you enjoyed this journey through the universe, don't forget to subscribe to the channel, because next time we will explore another mystery, a mystery that may be even bigger than the Great Attractor itself. Until then, keep looking up, because the universe still has many secrets left to reveal.